This is a short film by the Houston pilots in cooperation with the Port of Houston Authority regarding the urgent need for dredging in the approaches to the Houston Bayport Container Terminal. Over 11 years of study and research have demonstrated that post-Panamax ships cannot safely maneuver through the existing Bayport flare entrance to the Bayport Terminal. This navigation barrier is barring the door to the newly constructed Bayport Container Terminal, as Bayport's cranes are designed for the new class of post-Panamax ships that will be in service upon the opening of the new Panama Canal locks. Additionally, this existing channel area is a notorious and treacherous hotspot in the middle of the Port of Houston, contributing to over 12 deaths, numerous collisions, and uncountable near misses. These hazards are due to the turn in the channel, which is dangerously located in the middle of the confluence of three busy waterways. This needed dredging will straighten the channel, measurably improving safety in the area, and it will create a conventional navigable turn in and out of Bayport. The productivity impacts to the Port of Houston are being realized today. 1,140-foot by 140-foot beam container ships, loaded at 40 feet a draft, such as the Susan Maersk, are currently being refused into Bayport Terminal because of the danger in the approach turn. These larger ships cannot safely negotiate the zigzag approach into Bayport. Inbound, the channel approach requires the pilot to initially turn to the right and then back to the left. This maneuver requires a massive shift of the ship's inertia from the commitment of the initial right turn back again to the left towards the terminal's channel. Numerous studies conducted at the U.S. Army Corps of Engineers in Vicksburg, Mississippi, and other established simulation facilities have supported the position of the Houston pilots that this maneuver, combined with the narrow channel clearances in the Bayport approaches, is not acceptable for safe navigation of post-Panamax container vessels. The Houston pilots feel strongly about this and have constructed a scale physical model of the Bayport approaches, including constructing a scaled post-Panamax container ship to conduct scale model testing. The scale model tests validate the results found in the simulators, that the proposed channel easement on the right side of the entrance channel, along with a redesign of the Bayport flare to a 4,000-foot constant radius, would provide the best overall improvement to navigation safety. In this typical example from the model testing at the Maritime Pilots Institute, the scale model is proceeding inbound to Bayport in the existing channel, and the vessel is unable to maneuver into Bayport, ending up aground. The vessel was maneuvered in a conservative and typical fashion by the pilot. Due to the restricted channel and the required initial right turn into the final left turn, the ship's inertia into the left turn commenced late, and the vessel could not turn fast enough to make it into the channel. Going faster in an effort to make the ship turn faster only causes the ship to squat down to the bottom, further impairing her turn. Using the tugs to assist is possible, but they lack the room in the existing channel to work properly around the ship. Thus, the channel is too tight for this ship to consistently make safe turns in and out of Bayport. The Houston pilots and our many research partners and stakeholders supporting safe navigation access into Bayport feel that the due diligence of 11 years of study is compelling and consistently indicates a need for dredging in the flare and channel areas. We thank you for your attention to this important issue as we pledge to continue our investment and support for the success of the Bayport Container Terminal.